Good afternoon, everybody. Welcome to this session. My name is Jeremy Love. I'm the CodeStack STEAM coordinator. Um, we're going to be doing we're going to be working on some projects together. So if you have your computers, please be prepared to do that. And if you have any kind of problems, you can just type in the chat or the Q&A. I'm just going to try to answer things as they come through. I'm going to put my email address in the chat, and you can always email me if you want further questions and anything you say. I'll be monitoring the chat and the Q&A. Also, um, I have a Google site with our presentation on it, and I'm going to share that with you. All right, I'll share that with you at the end. And yeah, let's just get started here. So let me pull up the slideshow. Okay, so we're going to be talking about storytelling with code. And first, let me tell you a little bit about myself. Like I said, my name is Jeremy Love. I'm the coordinator for CodeStack STEAM. San Joaquin, I've been with the San Joaquin County Office of Education for 10 years. Most of that time, I was a classroom teacher. I've been a tech mentor for other teachers, and I've also been a curriculum writer. I worked with the University of California and their CTE pathways. We integrated CTE classes with academic classes, so like arts and media with English, or math with music. So and that was fun. I was a curriculum writer, a grant writer, and a course team facilitator. I'm also a graphic novelist, illustrator, and animator. I've worked for DC Comics, Disney, Sony, Fox, Cartoon Network, Rockstar Games. I still do that. That's one of my passions. That's why this session came to me. The using technology as an artistic tool and as a storytelling tool. Okay, so let me tell you a little bit about CodeStack STEAM. As you know, CodeStack is a entity into itself with software engineering. Well, we're bringing that to high schools and elementary. We're trying to bring that STEAM education in a new, innovative way. So we are working on a curriculum. We're developing a curriculum that's modular, that's integrated, and that's continually updated. But more importantly, we're working on building a team that offers mentorship, learning communities, and professional development for teachers who may not have a lot of technological skills, or may not be comfortable teaching computer science, but are willing to try. So we're trying to bring that to give them that opportunity. We're developing a comprehensive 9 through 12 computer science course. It's going to be based in robotics, video games, computer graphics, wearable technology, a lot of physical computing, streaming music, smart devices. Um, but this course is being designed for everyone. It's not an AP computer science course. It's a computer science course that anyone can participate in. Let me just make sure I'm monitoring that chat. My chat window. Oh, there it goes. Okay, so our curriculum also is satisfies the 9 through 12 computer science standards. One of our writers, Steve Callahan, was on the team that wrote that curriculum. It's also been approved, A through G approved by the University of California, so it meets those requirements. And it's also aligned with CTE standards, the Information and Communications Technology pathway. Okay, so just my philosophy about us using technology in the classroom. Um, and I've used technology pretty much my whole teaching career, and uh, the things that I found is I like my software. I like my platforms to be free. There's enough free software prep platforms out there that you really don't have to pay for anything, especially at the secondary and elementary school level. Easy to learn for teachers and students. A lot of this time, a lot of teachers, when they take on these projects or take on computer science projects and are not computer science teachers, you'll be learning along with your students. And sometimes your students can teach you a lot. The physical computing aspect will be low cost. We have to protect student data safety. We know that's a must. And one of the most important things that people overlook is widespread community support. So do they have YouTube channels? Is there tutorials? Can you have access to training material or ways to find out how to create things? So that's my criteria. Okay, so um, in addition to teaching computer science, I've taught art, I've taught English, history, integrated classes, science, and I've always found that the ability to tell a story or write a narrative is an essential skill. And we know students have to write and they have to create do narrative essays and make presentations. But what if we could use computer science as an alternative assessment tool? Instead of that slideshow, what if they make an app or create a game or do a choose your own adventure game or make an animation? Um, this session is designed to give you some tools and give you some ideas on some alternative types of ways of assessing your students. So you might teach history, but instead of a essay or a poster board or things like that, what about a short animation? And it's easier than you would think. And as an added bonus, students flex their creative muscles, they build their computer literacy. And I also find when they're doing this type of out of the box creative forms of gauging their knowledge of a subject matter, they have to know more about it. Their knowledge has to be deeper in order for them to create a compelling art piece. Um, the things that we're going to be talking about is based in block coding. So, and if you see on the left of the screen here, um, that is the written JavaScript code. Block coding is converting all that written coding language into blocks that are easier to understand and easier to connect. So it's kind of like Legos. Instead of writing code, you're connecting pieces of code, and it's essentially the same skill. Okay, so the first one we're going to talk about is Scratch. And Scratch is ubiquitous. It's everywhere. It's block-based coding language for students. It's great. It's a great beginning platform, and the the jumping on point is low, but you can go as high as you want. You can get as complex as you want with your creations. It's supported by a vast community of scratchers or so you have YouTube channels, you have all kinds of tutorials out there. Anything you want to figure out how to do on Scratch, you could probably find it within a matter of minutes online. Okay, so CS first, and I am going to put this link in the chat. And why don't you guys come with me and explore CS first. You guys can just go ahead and go to the website. I'll just CS first, created by Google, offers free computer science curriculum that incorporates Scratch. It's really ideal for elementary age students. It could be taught as a whole course, or you can teach it in individual lessons. And it also integrates with Google Classroom. Of course it does, because it's a Google um, creation. But you can explore here the curriculum. Um, they have resources, videos, but I'm just going to go over a few things here. Their storytelling tools. So I have another link here, and it's to their curriculum. I will put it in here. And don't worry, did I put the same link there? If you go to the same link, just click curriculum, and you'll go down and you'll see all of these 1 hour activities You can use these activities as a way to train students in how to actually like execute a project like this, and then they can use those skills and apply it to other subjects. So let's look at a few of them. Let's look at a dialogue. It's really click start. Actually, I want to go to the examples. And if you look at an example, we're going to look at the code inside of here. So if you see these codes, when the green flag is clicked, wait 6 minutes, wait 6 seconds, and then you say all of these things that it's just the narrative, and let's just play it. Watch the code as it moves on. Stop that. Each sprite has their own, each character has their own script, and you just pull all of these out and connect them together. There's the sound. You can open up existing material and change it, but it's a very simple um, learning curve, and CS First teaches you how to do this. I'd say a student can be doing something like this within the first day of learning CS First. I mean, Scratch. Let's do some more. Let's look at some more examples here. This is a cool example. Instead of a regular presentation, what about an interactive, like animated presentation? And these are student examples, by the way. I mean, we could come up with something more sophisticated, but these are things that students are coming up with. And let's look at it a little bit. Then I'm going to show you inside. I'm going to show you the code inside of it. So if you go into to the code, you see how they had the dialogue blocks, and these blocks are here. So you pull out a dialogue block and you can type in it. They have their costumes. So the little character has several looks, so you can animate it. And then we have several backgrounds. You look at all the different backdrops. Well, all these things are put together to make an animation. I mean, a presentation that's different from just regurgitating information. Let's look at one more. Let me go back here. And like I said, I'm going to put these links. You can explore it yourself in the link. I'm just giving you some possibilities. Let's look at the figurative language. This is a language arts example. Now we're going to go from young age and get gradually higher. But as you can see, look at the code here. Okay, so let's go back. And that's CS First. I showed you that example already. So if you want to turn this into a whole course, they have like a 8 to 12 day, assuming that you teach an hour a day, they have an 8 to 12 day course where you can take them through the whole process of storytelling. And at the end of this, they can create a mini animation. So this might be a good, and this could really be integrated with the language arts class where they're writing a story and then executing it. All right. Now we're going to get into some hands-on stuff. Code.org massive computer science learning platform for all ages. And they even get student, they even have materials that prepare students for the AP exam. But you don't have to go that high with it. So it has a variety of programming environments, a massive library of tutorials online and all over the internet, and they have lesson plans that can last a day or full-blown year-long courses. So PlayLab is a programming environment where you can make simple animations and games with objects and characters that interact with each other. Let's do this together. I'm going to copy and paste this link. And why don't we try it together? And you'll see how simple it is. Now, you don't have to play the video. I haven't posted the info yet. I was going to put the website at the end. Oh, okay. So the one I posted first was CS First. I can post that link again. There you go. And then now we're going to do an activity together. The hour of code. I mean, this play lab. Now it says an hour of code, but it would take an elementary kid longer than it will take we as adults. Or hopefully, I don't know about that. We'll see. So let me close these windows. All right. So I'm just going to click out of this video. And this is the cool thing about this code.org platform. And I would suggest if you're not comfortable with computer science, just go ahead and jump in and learn with the students. I mean, you guys can all learn together. So you click OK. Waddles wants to say hello. Can you help him? So we're just going to drop this block in. And we're going to type hello. And then we're going to run it. There we go. Now, you can keep playing. If you need help, there's a solution here. Okay, let's. And you continue. Let's try to get to the end of this. I'm gonna go ahead and work on it. You guys work on it. Let's try to get to the end. All right. I'm gonna put actor 1. Remember, you can't get the solution. You can always click there to get the solution. Oh, I didn't put hello here. There we go. So as you can see, they're showing you how to do certain movements, but a student can string together a series of conversations and actions to make their own mini animation. And that's what it'll build you to. So she wants to get the flag. The flag is which way? It's right, I think. Let's see. So the tennis boy wants to get the tennis girl. So we're gonna move him. Let's do some trial and error. These are all the different sounds it has. Let's see if I, there we go. One of the most important things when you do something like this is to let students fail. Like if something happens, let them fail and try it again and try it again and try it again. Okay, we're almost there. There we go. Uh-oh, something's not right. Oh, what's the solution? Oh, wind run. Oh, what happened? I'm just gonna move on. Something happened there. All right, 6. Remember to use these. Okay, here we go. I'll go over there. There we go. All right. Okay. You got your loops. Play a sound. Go. Couple more. Almost done with this one. they want you to change the speed. Last but not least, in this one, you create your own game. So we're going to go ahead and skip that. And okay, so that was Play Lab. This next one, App Lab. Now this gets a little bit more serious. In App Lab, you can actually create a simple mobile app that can be sent to your phone. So just imagine, instead of your student creating a presentation, just imagine they created a mobile app that they could distribute and share via a link to any telephone. And we're going to try that out. It's not as hard as it seems, but it has a really satisfying end result. So we're going to click this. I'm going to put this link in the chat, and I hope you guys can come with me to view the App Lab. While you guys get that link, you shouldn't have to sign in to code.org, but you can sign in with Google if you want to save your projects. A lot of people shy away from this kind of thing because they think it requires a big time commitment, but it really doesn't. I mean, you can jump in and out of these kinds of projects. Let me hit continue. All right, let's start here. Oh. So this is the App Lab environment. As you can see, it's slightly more intimidating than the it's slightly more intimidating than the Play Lab because it's designed for older students. So let me zoom out a little bit, see if I can. There we go. Oh, I zoom in again. I can zoom in and out. Okay. All right. So we have over here, we have our simulated cell phone, and here we have our codes. Now, this one, when I teach this sometimes, and after the students get more comfortable, I even introduce written code, which you can actually write your code out, but we don't want to go too far. Let's show blocks. All right, so it's very easy to see, and then let's get through this, and at the end of it, let's try to send it to your own cell phone and look at it. So make the screen green. So set property screen 1 to background color green. Run it. There we go. So I completed this already, but it wants you to make the text bigger. So you need 2 lines of code. So let's say these were out. Okay. So you're going to set the property. This is a label. If you hover over it, you'll see what the name of the object that you're setting is. And this wants you to make it bigger and blue. So I'm going to text color. They want it blue. All right. Then I'm going to put in and they want the text size. Oh, we only need two lines then. It's 80 now. Let's make it, I don't know, 120. Probably too big, huh? Let's try 85. There we go. I hope you guys are following along. If anyone needs the link or has a question, let me know. but it's very simple. We want you to make this one red, this one blue. Now, let's take these out because I've already done this, so I'm kind of cheating. So I'm setting button 1, the background color to red, button 2, the background color to blue. And they want this to say, welcome to my app. And then run it. So you guys can use this as a kind of a cheat sheet. Let me start over. There we go. So that way I can show you from scratch. Okay, so we need set property. What's this called? Label 1. They want you to change that text. They want it to say, welcome to my app. Then we got to put another block for 2, button 1. Change that to, change the color, text color. I mean, they want the box or the text. They want the box color. Background color to red, and then the same. This is button 2. Blue. And run it. All right, there we go. Okay, so we finished that. Go to the next one. Now we're going to make it interactive. Let me clear this again. Not clear. Go to my version history, start over. All right. Add code that turns it green when you click Greenify. So on the event, when you click the big button click, set property of screen 1 to green. Let's run it. There we go. So let's go ahead and work through these, and I won't direct you through each one. Let's see if you guys can get a few of them. So that's screen 1. Background color to, it says black. Black is the 000. That's label 1. So this one, you already see on button, on the first button click, screen 1 will turn white and the text will turn black. And on the off button, screen 1 will turn black and the label will turn white. Let's run it and see. On, off. Oh, I have red. Look at that. Here we go. Work on this for a few more minutes and I'm going to show you how to yeah, I think this is a good, this part of it is a good one to create. And then send to our phones and see how it works. So here we go. Just follow the directions closely. Set property. Button 4. You can choose a picture. You can upload one, or you can, since I don't want to upload one right now, so we'll just go ahead and I'll just use my avatar, I guess. Oh, that might not fit. Oh, there it is. That's good. So there goes rabbit. So 1, 2, you created a new image. Now you can run it. Oh, I don't have a sound on mine yet though. So I'm gonna need to put I'm also gonna have to put a set property to change the text. And I'm just not gonna worry about the sound part of it. Oh, what did I do there? Don't click finish yet. If you did, you can go back. Okay, select this right. There we go. Oh, rabbit. Oh, I deleted my image. All right, now here we go. All right, so now we got this done. Let's send it to our phone. So you hit share. You can either publish the link and your student can send it to you, or you can send it to your phone. So click phone. I'm gonna send it to mine. Well, if you guys are gonna have my phone number for a minute, get it while you can. If you, all right, I sent it to my phone number, my phone, and I'm gonna show you. There we go. I got a link, and let's let it load. I'm gonna stop sharing my screen real quick so you can see. It's loading slowly. Come on. It's real slow. Here it comes. See, studio. And then you should be, there it is. Can you see that on my phone? And it works? Okay. It's still loading, but should work. Come on. Oh, do I have my sound off? That's why. There we go. So there we go. So you can actually create, I'll share my screen again. I mean, that's not something that you have to do a whole dedicated class to. You could actually teach that as a standalone lesson. I mean, as like a standalone lesson, and then use that for students to turn in work. Okay. So yeah, so I'm going to put the link. First of all, are there any questions? I'm going to open it up to Q&A. And if you want to go back and continue playing with App Lab as we go through this, then you can, because there's all kinds of things you can do. Especially, it'll take you to design mode, where here you can design a choose your own adventure game. So I kind of think mine's already designed. You went right, you went left, and this takes you through the whole process of creating like a choose your own adventure. And you can have as many screens as possible. It can be as complex as possible. But I just think it's a really good, engaging way to spice things up, or to engage your students and have them use parts of their brain that they don't usually use, or even to build that computer literacy. I want to send this to myself too. Now I'm going to put the link to my Google site. And this Google site has the entire presentation on it. There we go. And that should work. My last session, I had to change the settings, but on that session, you'll find all of these links at the end of that presentation. You'll find the whole presentation too. I'm actually going to I'm going to add my email address to this presentation. That way, if you have any questions, you can shoot me an email, and I'll be happy to help you out in any way that I can. There we go. Should have done that before. So we can keep playing with this if you want to, but let me see if there's any questions. Thank you. I'm just reading some of the comments there. Yeah, I actually find most of my teaching career was with I had at least a third of my students had some sort of IEP, and I had to accommodate many different learning styles. And the good thing about this is students will some students will pick it up faster than the other ones, and they'll feed off of each other. So you can have students helping each other. And a lot of students who don't respond to maybe writing something or having to write an essay, do a PowerPoint or something like that, they will respond to actually creating and coding. You'd be surprised. I'm sorry for the noise. I'm sitting here, I'm in the SJCOE Fab Lab, if you can see. Very large makerspace full of fun things to do. So I thank you guys for attending the session. Like I said, I have my email in the presentation, and you have my presentation. And I really appreciate you taking this time with me, and I hope you enjoyed it. Goodbye, everybody. If you attended my previous session, both sessions are on the link that I sent to my website.